And yes, I am so happy to have Charles Macfadyen joining us today. So Charles is the General Manager of Drilling Optimization at Imdex Limited. He brings over 20 years of experience in mining with specialist skill sets in all forms of drilling, from mineral exploration to underground mining. So it is going to be awesome hearing his insights today about drilling fundamentals for geologists. So keep using the chat. We'll be opening up the floor at the end. I hope you all enjoy it. And yes, thank you so much, Charles, for joining. It's amazing having you today.
Yeah, so thanks for the intro. I guess I'll try and enlighten some on a little bit of drilling, but it's probably talks a lot about some of the things we can start using today and probably asking ourselves some of the questions of why we're not using them. So I'll go through a few slides and then we'll open up the floor to some questions. So feel free to reach out directly and ask them as we go, or wait to the end. I think some of you might have seen this a little bit before from Michelle Carey, might have used this geology, or if you trawl the internet, you've probably seen a slide like this before. We talk about geologists and drillers, sometimes opposite end of the spectrum. So let's try to look at what would we describe a driller, and you can see some of the things that I probably put in the box that explain the difference between a geologist and a driller. And one of the most things that I was thinking about is when we talk about Dante's Peak or a movie scene, I think every driller would probably relate to Armageddon. And I look at what's the difference there. I think that both a geologist and a driller fancy themselves as saving the world. So maybe I can enlighten you as we go through of how I see drilling saving the world, and us on some common goals here to promote the industry, do things cheaper, do things faster, and unlock the value that comes with, I guess, very expensive drilling programs. This is probably a common sort of index slide, so try not to index size too much of this. It's not really a sales pitch, but bear with me as we go through some of this. So really looking at the mining value chain across the bottom and how important drilling is and represents across different aspects of exploration, all the way through to definition and extraction. We see the aim is to test more targets, but like I said, these are really getting more and more expensive multi-million-dollar drilling programs. And so I'll try and share some insights into sort of some simple things that you could use now. There's still some big challenges that face us with what the modern equipment of this world looks like. And you'll see some of those there, but I won't talk too much to that at all. But, you know, I guess it's really about drilling smarter and how do we get that evolution of drilling to happen? And does everyone know enough about it? And are you asking the right questions to really maximize outcomes? So hopefully I can try and share some of those things of the way I see the world. And maybe you can apply them given your operations. I guess the first part for me is when you look at exploration drilling as a whole. I think this is where you start talking a lot about the OEMs of this world and what are they doing. Like I said, I have probably spent some time with and working for one of the OEMs. They will have a variety of roadmaps that break down what automation and the future of drilling looks like, where productivity and more autonomous features will come, less people, higher productivity and stuff. But I guess the quest is, when is that coming? We've seen that chapter be unlocked in mining when you talk about underground mining or surface mining. But when you talk mineral exploration, there's still a lag here. So the technology is ready. I think it's capable. It's just, how do we turn that on? When we turn that on, what do we need to consider? So I think you'll see a variety of different and more autonomous features coming sooner. Is that 1 to 2 years? Is it 3 to 5? I guess your guess is as good as mine. I think it's ready now. Probably waiting for the first to start asking for that and deciding to utilize it. And that probably comes from a lot of you on this call, to start challenging and looking at how we motivate that change into the next gen of what drilling looks like. Imdex across the axis, across the bottom, I guess we keep abreast of what the equipment looks like as we have to start integrating with different workflows, whether it be some of our rock knowledge sensors or other drilling optimization features that our wheelhouse is not in drilling, but we play heavily in those workflows. So staying abreast of when people start not being on a rig, how you have more and more autonomous features is something we need to obviously keep an eye on. What I will talk about is probably 3 things that I guess you can use now to optimize your drilling programs. And really we need the industry to turn the corner and embrace some of these analytics, these smarter fluids and directional drilling to really take off. And I'll try and share a little bit of how you might use them and what it means to your operation. So like I said, the first one I'll talk about is smarter fluids, how to start using that chemistry. It is a science. It is something that's been heavily used in oil and gas, and it does unlock form and function when it comes to drilling. And it's a really simple starting point for most to understand a little bit more about what fluids are put down the hole and why they're important to getting a quality core to come back out of the hole or to aid depth and performance. So I'll share a little bit about the smarter fluids. We talk about drilling analytics. We're talking about, I guess, a little bit to do with what would you say, time in motion and workflows around drilling. So where the activity is spent, what you've been doing, and then absolute performance. So we start looking at rate of penetration and key metrics, and then using that to make different decisions about drilling outcomes. So I'll share a little bit about a business that we've just invested in. We've been in this business for probably 12 years or 12 plus years, and show some of the power that can come from drilling analytics. And it's really the first chapter. I think the industry's starting to see more and more of this. And as geologists, I would ask yourself, why are we not using that data set more? I think we're becoming more and more experienced with the rock knowledge data sets. But when these 2 signals come together, you start unlocking more and more possibilities and driving better outcomes, like I said. The 3rd chapter is a little bit about directional drilling. The benefits that come with mother and daughter holes and the ability to look at, I guess, a different program altogether. It may be similar to obviously a diamond core drill and drilling program, but the ability to do mother-daughter holes and drive different outcomes where you're able to steer right off and understand an ore body. Big ESG benefits of minimal disruption of the surface or the land itself, as you touched on, Jess. But able to achieve some radical results. And I share a case study from something in Finland where the magnitude of savings is 23.6 kilometers of drilling that was able to be saved, which had a huge saving to the resource company of cost, but also time and understanding an ore body. So these things together, one can be used today, but when they start marrying up with ore body knowledge, you're going to start seeing this really unlocking the value and really making a significant difference to your operations. I see they're all very stable signals. They're trusted data sets and insights. I think they really unlock those productivity increases that we all come to expect and want to see more of. And I guess there's more creative ways to make them commercially viable. They're not overly expensive. Some of them, maybe directional drilling can be if you consider it, but it's still, I would say, not that expensive in the bigger scheme of what a drilling program costs. So we were talking $10 million or so for a drilling program. These things are probably still quite cheap in significance compared to some of those operations. If I start with one, unlocking fluids is, I guess, not unlocking fluids, I'd say leveraging that technology today. I think when you look at a drilling operation, you'll see this sort of ugly side of a drill where these mud tanks and hoses and different apparatus to mix and store fluids. Oil and gas probably treat this more like the science that it is, that they use that chemistry to a precise nature where they get drilling outcomes, whereas you'll still see a lot of drillers in the industry rubbing their fingers through that fluid and assuming that that is the right consistency, viscosity, and other attributes of the fluid that needs to get down the hole to aid function. I've never seen that be accurate to use your fingers. Geologists probably may lick the rocks and get a degree of accuracy from that. Maybe that's a bad joke, but Daniel, you could probably use that one at a later date. But I think there's a lot more smarter features out there that you can use. Imdex stay abreast of that. One of the core businesses is AMC, or a fluids business. Digitizing that knowledge and making it available for others is definitely one of the chapters that we're just unlocking now. Tomorrow it leads to probably more AI and dosing type autonomous systems that allow it to be done automatically. That's not mainstream just yet, but really leveraging that knowledge and science and applying it is something we see we can digitize and aid others with. So unlocking those ESG values that come, productivity and cost efficiencies. If we look at, and I'll just bring up sort of three parts to fluids that I think are relevant, and maybe some know it, maybe don't, maybe some don't. But ultimately, managing a system of drilling, when we talk diamond coring, is managing that fluid and cutting transportation. So, you've got a system that pumps fluids down the hole, out of the hole into a sump, and then recirculates it, right? And there's a few different bits of equipment that you can see on different operations, but effectively it's a small system transporting that around. Number one is really, water is generally not easy to get at most of these drilling programs. So maintaining that fluid that makes that system work is pretty important. So when you start getting cavities or fluid loss that happens, and it's generally happening down the hole where you've got porous geology or areas where it leaks, it's having preventative measures in place to maintain that or plug that gap or that cavity, to obviously keep fluid in the hole and then aid that fluid, getting down to where it needs to be, which is to aid cutting. So it'd be like running a lathe without, cutting fluid and so forth. You're going to end up with catastrophic failures, and the ability to really maintain hole integrity or hole quality. So I think, having a proactive fluid loss fluids in your drilling system, basically there's preventative measures that you can apply so there's always properties there, and then you ratchet up as you start encountering these fluid loss moments. And then there's even some deployable tools that will drop down the hole and inject a specialty fluid right to that area of intersection, which will allow you to drill. So having the confidence to understand this is a problem and then call it out and use those more premium fluid programs is a huge benefit. But still, we see a lot that probably make do with something more basic and not opt to use these fluid loss measures when needed. Obviously, they probably start to use them, a lot of drillers, when they really hit really troubled ground, but sometimes there's more preventative measures, like I said, to start using them. And the next one is really around lubrication. So what we're talking about, lubrication, pretty straightforward, but allowing the drill string to reduce drag and cut more efficiently, and improving that transportation of those cuttings and clearing out the bit face. And then we start talking a little bit about increased bit life. So obviously a lot would probably know this one, but the bit is the cutting force on the end of the drill string. Sadly, that is consumable and wears out and is the main contributing factor to performance. So when we start drilling deeper holes, there's a lot of challenges with pulling out the rod string out of the ground. So if we're at 500 to 1,000 meters, it's a lot of time taken to pull that pipe and change a bit. So how do we manage that bit life and increase performance, especially lubricants that we can add to that drilling fluid? to prolong bit life and manage that cuttings transportation. And you can see some graphs here. It's not radical, but you can see, quite quickly, 20% uplift in bit life performance would not be radical. In other places, it could be even greater than that. But it just depends on the geology and the ore body that we're tackling. But generally, you'll always see an input of prolonged bit life and performance when we start using lubrication. The other one is really around, I guess, the quality of core and encapsulation. So allowing those cuttings to coat or create a barrier around those surfaces and holding that water sensitivity and geology together during the drilling process, so it's not eroding all of that core and you sort of drill 3 meters and come back with only a meter of core, which I'm sure some of you have seen. It's making sure that core stays together and we get a representative sample that depicts that meter of drilling or 3 meters of drilling. So I think, that's another common challenge, and using certain fluids to manage that encapsulation process. There's a lot of chemistry, like I said, that goes into developing fluids, and there's a lot more than here. There's probably at least another 2 other key chapters that you could understand a little bit more. But I think reaching out and asking some more questions to drillers, I think asking more questions to other providers or fluid providers of what can I learn or what do I need to know based on my geology. So these 2 skill sets almost go hand in hand. You need to understand the geology to understand what the chemistry of the fluid to apply to it. So opening up those conversations is only going to benefit a lot of your operations. I'm not a chemist. I have some chemists that work for me. I'm probably not always the right answer in every part of that, but there is a huge uplift that comes from a relatively simple process of adding the right fluid to the right drilling program. So definitely something we can start considering. If I start looking at drilling analytics, I guess this is probably a little bit more closer to my heart of something that I see as being a driving force in mineral exploration of the future chapter. This is providing a digital signal of drilling performance, like I said, time in motion, what given drilling activities are. Most commonly used a little bit for invoicing and chain of custody between a geologist or a resource company back to a drilling operation. So filling out physical timesheets. What did we do? What assets did we use? Do you accept that? And generating an invoice. But there's also, like I said, that time in motion and performance metrics that comes out of solutions like this. One of the solutions I talk a little bit about is Crux, which is something we invested in the last 12 months, 40% stake in this business. And like I said, we've been in it for 12 years. Before that, we had a solution called Mobile or DDR. Crux provides us with a new digital platform to be able to do a few more things that the industry is going to need. And that starts looking at aggregating sensor data. So when we talk sensor data, I guess we're pretty familiar with sensor data that comes from rock knowledge or ore body knowledge. We're talking about the sensor data that comes from a drill here and aggregating that together. So it can actually be rock knowledge as well, but we're generally talking about feed, rotation, and certain drilling parameters on the rig to get a signal of performance. So that can be used in many different ways. A lot of drilling contractors will use that to aid their own performance and maximize different crews or different rigs to lift performance so they can lift a baseline. Others will start using it for training purposes, training new people. But I guess, this opens up a really good conversation between driller and geologist to what's really happened in a given operation. When we start having these digital signals, we're starting to talk a little bit about this digital driller. So a little bit different to automating drilling. You could potentially use sometimes this signal to control drilling. Let's say we don't. we're talking about a very digital backbone to aid drilling performance. All of this is sort of done with cloud analytics and provides insights, dashboards, ability to share these data sets across different platforms. And then when we sort of talk about value chain optimization and answer products, this opens up what is that next chapter and how do other data sets marry with this and what other products could be made. So I guess the voice we don't hear as much sometimes in this chapter is, what would a geologist really want to see from this data set? When we start talking about marrying up drilling performance data and rock knowledge or ore body data, what would that look like? What would we want to see? And so that's probably a little bit of my call out to the group is, I guess, why don't more geologists use drilling analytics or start asking to see that? Maybe you are, and maybe that's something that you're all reaching out and asking and wanting to see more and more in your drilling programs. But I think it's a very valuable set of data that you can all benefit from today. And then you'll start seeing it's on more and more operations globally. When we look at a data set here, this is just something I sort of put together. There's many different features or values that could come out of this. But it's really around, having multiple stakeholders be able to look at drilling performance at any time and having those visual dashboards that sort of explain what's been going on. So understanding what that means and how you'd use it. So one of the things when I talked about drilling bits before and how that aids performance, having calculations around drill bit economics is able to really maximize any operation. So, the challenge of a drill bit is obviously to aid performance and is one of the main topics that will drive performance. And that dance is often between, I guess, performance and life is the equation of what most drillers will be starting to look for, is how do I get a certain amount of performance but prolong life? Now, that's a choice that often is made by the driller. There are other potential combinations that could go into that. You could go for a more aggressive profile where you go for absolute performance, and that would come potentially at a sacrifice of cost. But, how many times are we asking to sort of see this data and ensure we're getting the right results? Or are we just trusting our drilling operations to provide that for us? So I think, having insights like this, you're able to click in there and see, different bit types and their performance, and probably drive a better conversation with your drilling contractors. In a lot of cases, they should and probably will maximize performance here, but sometimes that may not be obvious. So, having these insights that you can click together and just see how long or how quick a certain drill bit performed at depth, at what sort of understanding, you might be able to, look at changing a few simple things in your operation to really get a performance uplift. The changing a bit and changing and getting the right cutting structure would give you significant results or benefits to your operation. So obviously, a little bit of the value driver call outs below, a bit vanilla or generic, but there's an impact of ESG. So, less fuel burn to achieve a result. Productivity, you should be able to boost rate of penetration figures to be able to drill more meters per hour or more meters per shift and getting more core in the tray. That in turn unlocks cost efficiencies that could be used to either drill more targets or bring a drilling program in, or use even less drills to complete that drilling program. So definitely some cost efficiencies that come from only one small topic in drilling, which is drill bit economics. I've done a bit of work on this. It's probably a chapter that could last for a couple of hours, to be honest. It's a business I came out of in the past and probably pretty close to the heart as well. But I think for me, drilling analytics is here. It's a pretty powerful solution. Like I said, not too much of an internal sales pitch, just us, but there are options. There are a few people in the market doing this, but I would be asking, why are we not having that on every given drilling program to really drive the right behaviour and unlock the potential that comes from it. Third topic for me is probably directional drilling. This starts to get a little bit more expensive. So fluids programs aren't that expensive to implement or execute on. Drilling analytics is relatively cheap and powerful. You start getting a little bit more costly when you wrap sensors around a drill, but it's still cheap in significance to what it gives us. Directional drilling is a little bit more specialized. There's a few key pieces that I sort of display on the left-hand side of the screen. There's directional coring assemblies. Devico is a business that we bought. Once again, a little bit of a sales pitch, but the ability to core as you do a directional cut is one of the benefits of what Devico represent, as well as being, experts in navigational tools and rig alignment software. So very complementary to what we do well at Imdex, hence buying Devico. But we see this as an exciting new chapter. We've always had mud motors, which is another form of directional drilling, maybe a little less accurate or a little bit less scientific, but certainly can't take a directional core sample. But we see a lot of benefits in the industry unlocking the value that comes from directional drilling. Most would probably be aware of a bit of this. This is kind of quite precise drilling. To do this really well, it probably generally starts off with having a service layer that goes on top of that. So you're looking at almost an insurance policy where Devico provide people, trained experts in aiding a driller achieve outcomes based on directional control programs. So modeling from software, using the survey information to direct and steer that tool to make sure it achieves target, right? So it does add up to being a little bit more costly in some forms or operations, but the savings of magnitude can easily offset that. So it's still a really good solution. You're able to, obviously, you can see on the visualization on the right-hand side of the screen, the sort of mother-daughter concept. Maybe most are familiar with that, but obviously one mother hole and then being able to run a series of daughters off that one hole to understand and define that ore body, which is represented in that blue column we can see on the screen. So, instead of having to move that drill across surface and you can see some shorter stab holes there, we are able to really explore that ore body with minimal disturbance and set up and stay on that hole for a long period of time. So you can imagine you can have probably a driller, a bigger drill. You're not moving it around, so you've got a more comfortable, stable platform of where people can work. So you can have different kind of infrastructure around that. I just see that this is a really exciting chapter of how to do this well. And you'll see more and more innovation that comes with, more steerable solutions, more driller operable solutions. So it does start life a little bit with additional services, but I think there'll be next generations of this where we start becoming connected more and more to the drill and being able to do it more and more autonomously. If we look at a case study from Finland, this is where you start seeing some massive savings. This drilling program was able to come in. I'm just going to move my screen a little bit because I sort of keep getting everyone's faces over the parts I want to talk to. Total depth of that drilling program was around about 57.4 kilometers by using directional control and Devi drilling approximately 2 kilometers of it, because it's only used when you sort of kick off and then you'll return to normal drilling. There was being able to save 23.6 kilometers of drilling. In this use case in Finland, that equated to around about 12 million or 12.5 million US dollars of savings. Being able to save an incredible amount of time to define that ore body. And still maintain an incredibly high degree of accuracy. Up to 3% was probably the worst case, but often even quite precise in achieving a given location. So, there's differences in every operation. I'm not saying that you expect to see this on every site you go to, but it is significant when you start considering how valuable it can be to change to a different outcome. So, we're probably all by default revert to let's diamond core, let's stick to a certain size, and let's get to a certain depth. What if you started applying more and more directional outcomes over the top of an ore body, or understanding that? Would you see more? Would you be able to find more? Whether it be, a greenfields operation or more brownfields resource definition stuff. I think there's a huge uplift in what happens in directional drilling. Yeah. Are you asking it? Are you asking for it and looking for those? It's, like I said, it's a small insurance policy, some of these things on achieving better outcomes. So you could say fluids, like not big cost, but fundamental in achieving great results. If you looked at the second topic of drilling analytics, once again, not overly expensive to apply and start using it today, but drives the right behavior, gives you the insights that you'll need, and be able to start marrying that up, drilling performance with ore body knowledge. And then we start talking about directional drilling is, having skilled people that aid a drilling contractor to achieve better results, right? The drillers will always have a range of skill sets, and there's some pretty brilliant drilling contractors out there that will achieve great results and maybe using more basic technologies. But I think there's more and more skill that would come from leveraging some of these innovations and pushing them, or helping the market be able to drill faster and more efficiently than we see today. If I maybe sort of start getting close just to wrapping up, I don't know how we're going for time. I tend to talk away, and no questions coming through just yet, so I'm almost there. But I think, closing out for me, I see there's a huge part of the future which will be marrying up, like I said, a little bit around those two data sets. So if you've got rock knowledge and you've got drilling analytics, I think it would truly change the game and aid all of these more autonomous solutions. So, like I said initially, the drilling platform of tomorrow will be coming, and it will look different, and it will be different ranges of automated or automating workflows, automating functions. This is still something that we can do from afar when we start marrying up those two data sets and really drive our industry forward. So I think for me, that's unlocking success when we start being able to bring those two things together. Often we've thought about, if you look at it in what our roles are, geologist and driller, they're two things. This is a data set that's probably trying to say they're one and the same. So there's an incredible amount of value that comes from being able to look at those two things together. Drillability and understanding hardness can be interpreted from things like that. So, we need to understand what the geology is doing to maximize drilling, and probably vice versa. If you're looking at what geology are by, they go together. No driller, a lot of drillers would always quote or try and win jobs trying to know what that geology is to unlock drilling performance, so they can predict how many meters per shift they'll get. But there's a big multi-million-dollar operations, and there's some simple things we can ask ourselves. If I sort of go back to a little bit the start of, I guess, geologists and driller both want to save the world. I think that, once again, a little sales pitch here, but I think that comes through companies like ourselves, where we provide that platform where all of these data sets can come together and be able to share that and generate the insights that we all want to see. We might use that in different natures or different parts of all our businesses, but I think you start marrying those two groups together, and I think that really leads to success in the industry versus us and them sort of mentalities, which it may have been for some time. Jess, I might stop there with a bit of a Tommy Hanks or thanks for everyone. Hopefully I haven't made people drop off and fall asleep, but Daniel's jokes probably enlightened many to stay motivated. Sorry I didn't have too many more dad jokes as we went through this.
No, this has been brilliant. Thank you so much.